class we have discussed electric charge and its properties. In detail we have studied. Now we are going to discuss the second topic of the chapter, that is Coulomb's law. Consider two charges plus Q1 and plus Q2 separated by a distance r. These two charges plus Q1 and plus Q2 and the distance between them is r. They are placed in air. These charges are kept in air. According to Coulomb's law, there is a force of repulsion between them. This force of repulsion, why there is force of repulsion? Because both the charges are of same kind. So there will be a force of repulsion. Suppose if one charge is positive, other one is negative, then there will be a force of attraction. Now, according to Coulomb's law, the force of repulsion between these two charges is directly proportional to the product of charges, and it is inversely proportional to square of distance between them. According to Coulomb's law, the force of repulsion or attraction between any two point charges is directly proportional to the product of charges and inversely proportional to square of distance between them. By combining these two, we can express this equation as F is equal to a constant into Q1 Q2 upon r square. F is equal to a constant into Q1 Q2 upon r square, because Q1 Q2 the product is directly proportional and the square of distance is inversely proportional. So F is equal to K into Q1 Q2 upon r square. This is the conclusion we are getting from Coulomb's law. Once again, I says the Coulomb's law states that the force existing between two point charges is directly proportional to product of the charges and inversely proportional to square of distance between the charges. By combining these two equations, we can write the equation of force as F is equal to K into Q1 Q2 upon r square. Now we can discuss about this equation. This equation we can discuss in detail. We know that F is equal to K into Q1 Q2 upon r square. Now we are discussing about this K. K is the constant I told you. This constant value is 1 upon 4 pi epsilon naught, where this epsilon naught is a new term for you. Epsilon naught is actually the permittivity of free space. Epsilon naught is the constant called permittivity of free space, and its value is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. This is the value of the constant epsilon naught. 8.85 into 10 raised to minus 12. Now, when we put this value in this k, here we know that 1 is constant, 4 is constant, pi is constant, and this constant when we put here, we will get the value of k as 9 into 10 raised to 9 Newton meter square per Coulomb square. This is the value of k. How we are getting this value? I told you that 1 by 4 pi, in the place of epsilon naught we can substitute this value. So after solving this, we will obtain the equation as, we will get the value as 9 into 10 raised to 9 Newton meter square upon Coulomb square. This is the unit. Now we can write this equation as, therefore the equation of force we can express as, after putting the value, F is equal to, in the place of k we are writing 9 into 10 raised to 9. Then Q1, Q2 upon R square. F is equal to 9 into 10 raised to 9 Q1 Q2 upon R square. This is the equation we are using everywhere in numericals because calculation is easy with the value of k. No need of calculating each time 1 by 4 pi epsilon naught. In that place we can put this value 9 into 10 raised to 9 then Q1 Q2 upon R square. This is the case when the charges are kept in air. If the charges are kept in a medium, then here we have to write a dielectric constant. Its value will be given according to the dielectric medium. So this is the equation 9 into 10 raised to 9 Q1 Q2 upon R square. Now from this equation, F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. In this equation I told you already that epsilon naught is a new term for you. So we can obtain its dimensional formula. So we can express this equation as 1 by 4 pi epsilon naught we can calculate from this. That is what? F into R square divided by Q1 Q2. Charges, both are charges. So we can write Q square. Suppose both are equal. Then dimensional formula of force M L T raised to minus 2. Dimensional formula of distance, that is L square. Then dimensional formula of charge, that is A square T square. Coulomb square, Coulomb means AT, so A square T square. Therefore dimensional formula we can express as M, L is there, ML T raised to minus. So ML, here also L square. So ML raised to minus M L cube T raised to, when T goes here, when T goes to numerator, then it will become minus 2. So T raised to minus 4 will come, A raised to minus 2 will come. ML cube T raised to minus 4, A raised to minus 2. This is the dimensional formula of 1 by 4 pi epsilon naught. So for epsilon naught, what will be the dimensional formula? M raised to minus 1, L raised to minus 3, its reciprocal, T raised to 4 and A square. This is the dimensional formula of epsilon naught. M raised to minus 1, L raised to minus 3, T raised to 4 and A raised to 2. So this is about the Coulomb's law. So a new term we are getting from this, it is epsilon naught and its value I have told you, and a dimensional formula and unit. Unit we can write on the basis of this. So unit is Coulomb square, according to this itself we can write the unit. Coulomb square divided by Newton meter square. This is the dimensional formula. Now we can express this Coulomb's law. We know that in Coulomb's law, according to Coulomb's law, we are getting the value of force, an equation for force. We know that force is a vector quantity. So we can express this Coulomb's law in vector form also. Coulomb's law in vector form. I told you that two charges I am taking plus Q1 and plus Q2. There is a force acting on Q2 due to the charge Q1. Same way, there is a force acting on Q1 due to the charge Q2. Both are of same kind of charge, so there will be a repulsive force between Q1 and Q2. So here now, the force acting on Q1, F on Q1 due to Q2. Force acting on Q1 due to the charge Q2 we are going to write. So it is a repulsive force. We can express it as F12. That means force on first charge due to the second charge. We can write it as F12 is equal to, first of all, its magnitude, distance between these two charges, that is R. So F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square and unit vector R12. Because we know that here there is no vector quantities. So we are putting the unit vector. Here we can see that Q1 is at a distance of R from Q2. So the position of Q1 from second charge Q2, that is R12. The position of Q1 from Q2, that is R12. So we can express this equation as unit vector R12. Vector notation is must on both sides. Same way we can write the force on Q2 due to Q1. So force on second charge due to the first charge. Force on second charge due to the first charge is equal to, magnitude will be same because charges are same, distance is also same. So what is the force here? Force on Q2 due to the charge Q1, that is F21. And the corresponding position vector is R21. So here F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square unit vector R21. In this way we can express Coulomb's law in vector form. Whenever you express the equation in vector form, vector notation is must on both sides. Otherwise you will not get any mark. Now from the diagram it is clear that F12 and F21, these two are in opposite direction. So we can conclude this Coulomb's law in vector form as F12 is equal to minus F21. F12 is equal and opposite to F21. Its magnitude is same, but they are in opposite direction. So F12 is equal to minus F21. This is the conclusion of Coulomb's law in vector form. So this is the expression for a Coulomb's law in vector form. Now we have discussed here now two topics, 2 points regarding Coulomb's law. First of all, we have we have learned the definition for a statement of Coulomb's law, and hence we had obtained the equation for force existing between two charges. On the basis of that, we have discussed Coulomb's law in vector form. Coulomb's law in vector form is very important. Mostly they are asking in paper to express Coulomb's law in vector form. So you can write these equations. As a conclusion, you can write this also. This is the Coulomb's law in vector form. Now we are going to do some numericals on the basis of Coulomb's law. Numericals on Coulomb's law. First of all, we are going to do calculate the force between between a proton and an electron. Kept at a distance of 0.85 into 10 raised to minus 15 meter. Calculate the force between a proton and an electron kept at a distance of 0.85 into 10 raised to minus 15 meter. How will you calculate? Here the one charge is proton, charge of proton. Another charge is charge of electron. So this is Q1, this is Q2. So we have got two charges, two charged bodies. So Q1 and Q2 are 2 point charges. So the value of Q1, charge of proton, is actually positive plus 1.6 into 10 raised to minus 19 Coulomb. Charge of electron is minus 1.6 into 10 raised to minus 19 Coulomb. Then the distance between them is what? 0.85 into 10 raised to minus 15 meter. So we can calculate its value by the equation F is equal to 9 into 10 raised to 9 Q1 Q2 upon R square. Before that, one more thing is there. We know that Q1 is of positive charge, Q2 is of negative charge. So you may get the question, which kind of charge exists between them? It will be an attractive force because both are of opposite kind of charges. 9 into 10 raised to 9 Q1 Q2 upon R square. So we can put these values and calculate it. Put this value 9 into 10 raised to 9. We will substitute this value in the place of Q1 and Q2. 1.6 into 10 raised to minus 19 whole square divided by R square, that means 0.85 into 10 raised to minus 15 square we have to take because R square is there. So you can calculate it. So you will get the answer of force existing between two charged bodies. This is one question on the basis of this can be asked. One more question I am writing. Question number 2. Two charges are E and 9E, both are of positive, kept at a distance of 16 centimeter, 0.16 meter, kept at a distance of 0.16 meter, otherwise at a 16 centimeter. Now, where should a third charge Q be placed so that the net force on Q will be 0. Net force on Q will be 0. Or the net force, or we can say that Q will be in equilibrium. Now here, this is the question. Here I am drawing charge E and this is 9E. Distance between this is 16 centimeter. Here I am placing at a distance of X the third charge Q. So this will be what? 16 minus X. Now we can calculate what is the distance. They are asking at where should a third charge be placed. That means I have taken at a distance X from E, the third charge should be placed. The third charge should be placed at a distance of X from E. So we can calculate the value of E. QE divided by X square. F2 is equal to 9 into 10 raised to 9, 9E into Q divided by X, 16 minus X the whole square. We know that the net charge on Q is equal to 0. That means F1 will be equal to F2. So we can write it as 9 into 10 raised to 9 QE divided by X square is equal to 9 into 10 raised to 9 Q into 9E divided by 16 minus X the whole square. So 9, it is cancelled, QE cancelled. So we can express this equation as 1 upon X square is equal to 9 upon 16 minus X the whole square. So take the square root. 1 by X is equal to 3 upon 16 minus X. So we can calculate the value of X from this. We can calculate the value of X. 3X is equal to 16 minus X. So 3X plus X is equal to 16. 4X is equal to 16. So X is equal to 16 upon 4. That means 4 centimeter. That means from E, our diagram was like this. Here it was E. Here is QI kept, which is at a distance of X. And here it was 9E. So we can conclude that the third charge Q should be placed at a distance of 4 centimeter from the charge E. This is another question can be asked on the basis of Coulomb's law. So, rest of the questions everyone have to do all the questions. There are many varieties of questions. So today I am winding up the class. Two topics we have discussed here, Coulomb's law and Coulomb's law in vector form, and numericals on the basis of Coulomb's law. Thank you.